Hello everyone. So I'm hoping that you can hear me and that the music isn't too loud, because here's the plan today. I have about 2 hours of time, so I'm gonna actually set a timer for myself. I don't have my phone, but I'm gonna set a timer because I wanna see if we can get this done in 2 hours, because that makes it more interesting and just more challenging. So here's the challenge. I wanna build a dynamic generator for Mondrian style art with React and D3 tree maps. So this is the art that we're going after, and the reason I'm choosing this is because tree maps as a data structure and as a data visualization principle look a lot like this sort of thing. So we're gonna make it a little bit interactive, we're going to make it recursive because that will give us the tree-like structure, and I'm hoping that we're gonna find some interesting properties about this sort of thing. We're going to work on it in a I was thinking about doing it in a code sandbox, but I think it's gonna be better with an actual project. Hey Magdi, how are you doing today? So I'm gonna go to cd documents random coding. Oh, I never set the timer. So 2 hours, 2 hour timer. Here we go. No, that's alarms. Where's the timer? And I think setting a timer also makes it easier for everyone to know what they're getting into when they watch this sort of thing. So 2 hours, timer is set. Let's see if we can make this thing work. So we're gonna start with create React app, Mondrian generator, generate Mondrian generator. Yeah, let's do Mondrian generator. This is going to create our basic project. In the meantime, we can go on GitHub and start looking at making a repository for this, just so that there's something I can later share with you all as far as the code base goes. Mondrian generator, and we're doing a generator instead of an actual data visualization because I couldn't find any good data sets for us to play with tree maps, and the request that somebody sent on email was specifically about tree maps, so I'm hoping to help those people out. Generate Mondrian style artboards with React and D3. Oh wow, it's 10 p.m. Julian. Are you... Where in Europe are you? We don't need a readme. Create repository. Perfect. So that is created. We can now do git init, git remote add origin. We copy this thing over. Bam. And we say remote origin already exists. Oh shit. I did not cd into the thing. We said Mondrian generator like that, and we say git init here, git init, git remote add origin, blah, git status, git add dot, git commit -m, south of England. Nice. So yeah, 10 p.m. does sound pretty late on a Sunday, so but don't worry, you're gonna get an email with a recap of how this went and what we built and all of the code and widgets to play with in probably a couple of days in your email. So git commit -a, initial CRA stuff. Great, got that. Let's open the project. Web, shared photo album, workshops, documents, random coding, Mondrian generator. We run yarn start, and that will give us, that should start up the basic thing, right? Okay, let's see. That's taking a while to start up. There we go. We now have a basic app. 11 p.m. in Paris. Yeah, I'm doing it at 2 p.m. on Sunday because that's the most convenient time for me personally to live code, and the reason it's recorded is so that everyone in other time zones can also watch. Let's go into app.js, change it to React mode so that I get nice prettier. Maybe I can move the chat somewhere else. So we have the app CSS, we can keep the same thing. Header, no, let's remove the header. Do we need a header? I never liked how the basic app gets structured here. So that's the logo. Div is class name app, fine. And we're gonna add an h1 here that says Mondrian Piet Mondrian generator. Piet Mondrian generator. We add a paragraph that says, let's see, what should we say? Tweak the parameters, tweak the params, see what happens. See what happens. Let's see, do we have an art emoji? There we go. Art emoji. Let's do her. She seems like a baller. Is baller the right word to use when you're talking about ladies? I'm never quite sure. So we have that. Now we're going to create an SVG that's going to have a width of 100% and a height of 100%. I don't think that's going to work very well, so let's give it a style with a border, just so we can see where it actually is. 1 pixel solid red. So okay, it's not bad. How do we give it more height? Div class name app. Let's go into app CSS. Let's say that this has a height of 100%. What happens then? No, 100 VHS. There we go. That's a little better. It's not great. Min height. That's what we have to do. Min height 100 VH. And yeah, so 100 VH isn't actually doing it. So I'm gonna use what we have here. Why is the app header like that? Div class name app. Perp 100 VH. That should work. Border 1 pixel solid blue. Why is this part always the hardest? So that looks like it's getting the full height, but then my SVG isn't. Oh, I know what we can do. We can use some flexi stuff. So let's say that what should we do here? Width 100 works, height 100 never seems to work. So I'm going to use a grid, because grids are great. So let's find a CSS grid generator, because I know what it is. Layout it. Or we can use this one. So this should work. We need 1 column with 2 rows, and we need this row to be much bigger. No? Okay. Let's try layout it, because that one I know how to actually use. So we go into layout it, CSS grid generator, and we remove the columns, we remove one of the rows, and we do this. Voila, get the code, and we see that this what we need to do. So this is going to look like this. Display grid, and now the SVG part is right. So then we have to say header, because that's our header, like that. Voila, and we have it. Yeah, so the height 100% on the SVG did not actually work. Surprise, surprise. Oh, okay, it will work this way. Cool. So we've got the width and height of the entire SVG. Now we can start building a Mondrian component here. We're gonna start with the Mondrian component, and then later we're going to add some props and stuff. So let's see. Mondrian. Let's say that for starters, this is going to have a width of 500 and a height of 500. Later we're gonna make it take up the entire space. And let's see, import Mondrian from /Mondrian, like that. And we make a new thing, import react from react, and we export default const, let's do this, const Mondrian is a function that gets a width and a height, and it's going to return nothing to start with. So it's going to return null, and it's going to say export default Mondrian. Okay, so that is still all of the boilerplate stuff. We have mondrian.js, and we can delete some of the other stuff. What's it complaining about? React is declared, but its value is never read. Fine, fine, fine. What I can do though is delete some of the superfluous stuff that we have. So we remove the app test, and we remove the logo SVG, like that. Now let's see what happens if we return a rectangle with a width of a width and a height of a height. That should give us perfect. So we know where. Well, that was unnecessary. Why are Harleys always so unnecessarily loud? Makes no sense. So let's see, how does Mondrian do this stuff? Composition. Let's see. So he liked to make stuff like this. So this is our target, and we're gonna generate it dynamically, which means we're gonna need some fat borders and stuff like that. In the meantime, let's look at how tree maps work with D3, because I always forget the basic APIs I'm using. So we go into D3 and we find wiki, and there's going to be a tree map here, because I'm pretty sure there will be. Tree map, D3 tree map, create a new tree map layout. Now what this is going to do is basically all of the hard work for us. It's just going to generate the entire tree map, and then we're going to populate it with interesting stuff. Recursively so a tree map recursively subdivides area into rectangles according to each node's associated value. So that's basically what we're going to be doing. So we are going to need what? What are we going to need? Let's also add an X and a Y. So we're going to say that this starts at X 100 and a Y of 10, just so that we have some structure, X and Y. And then we say here we are going to render a grouping element, and that grouping element is going to position our entire visualization at a particular X and Y. So we say transform, and that transform is translating to a $X and a $Y. So this will now give us a rectangle that is positioned where we want it. There we go, that works. So what's the next thing we need? Next thing we need is to start playing with the actual tree map generator. So let's look at that. The tree map generator, how do you work? The tree map, we're going to say const tree map equals a, we need to add d3, yarn add d3. That's going to be the D3 library with all of the helpful data visualization functions, and also the generator for D3 for a tree map. So we import asterisk as D3 from D3. Hopefully Webpack is smart enough to tree shake that and not give us the entire library every time. But it's been a while since I checked if that actually works. Last I remember it did. So what do we need to pass into the tree map? And why is my mouse scrolling weirdly? Ooh, that's pretty. That's the pack layout. So tree map root lays out the specified root hierarchy, assigning the following properties on root and its descendants. Okay, so we say tree map. How do we pass data into the tree map? we need to create a new tree map layout. So we are then going to call this on the data, which we're going to generate here. So we're going to say data. If tile is specified, sets the tiling method of the specified function, returns this tree map layout, tree map size, tree map round, tree map padding blah. Oh my god, bird. Okay. So I don't know why the bird is screaming right now. Okay, let me go get the bird just so he stops screaming. Say hello to Kiwi, everyone. He's the screaming you sometimes hear in the background. Hi, Kiwi. And let me make myself a little brighter here. Okay, how's that? Okay, so we have the tree map. We're going to console log this. Console log tree map so that we see what we get. And now we need to create a hierarchy data set, which looks like this. A D3 hierarchy constructs. Before you can compute a hierarchical layout, you need a root node. If your data is already in a hierarchical format, such as JSON, you can pass it directly to D3 hierarchy. Otherwise, you can rearrange tabular data, such as comma-separated value CSV, into a hierarchy using D3 stratify. Oh, I've never used that before. What is D3 stratify? Is that new? Consider the following table of relationships. Ah, okay, so that automatically generates hierarchical data, but instead the returned node and each descendant. Okay, so we're gonna do it this way. We're gonna have to get a D3 hierarchy and pass in the data set. Now our data set is going to start. Why not working? That is a good question, Mehdi. Why aren't I working with TypeScript? I think it's just because when I run create React app, I don't get TypeScript by default. So then then I forget to actually implement it myself or to add it. Okay, let's see. Const data. For starters, let's do a root node from the specified hierarchical data. Ah, okay, so how are we going to generate enough data for a Mondrian style picture? We can start with, actually let's do it out here for starters. So we're going to say const data. Oh, I can? Okay, well, I can do that next time. So I think the hierarchy needs to be, let's see. Okay, so it's a node that then has an array of children. Constructs a root node from the specified hierarchical data. You can pass it directly to D3 hierarchy, otherwise you can rearrange blah. Must be an object representing the root node. Okay, so our data is going to be, let's start name. What should our data be? Because we're maybe using tree maps for this is going to be difficult, but let's give it a shot anyway. So if we have some data, how do we, so we have to represent the whole picture. So it needs to have children. This might be a little bit difficult, but we'll see how it works. So we're going to, let's just create values. Let's say this is value 100, and then it has a children. So these children will have some sort of random values. And these values are going to represent some sort of percentage of size or something like that. Yeah, that's going to make the most sense. So we're going to create children. Let's see, the first one is going to have okay, let's see, children with value 80. Then we make, come on, another one with value 80, and another one with value 80, but also children that have, so this is just, we're going to create a generator for this in a little bit, but we're starting with something a little simpler. So value 50, and then another child with value 50, and let's then add another child that will have value 50, and children that, where there's 3 children, or let's say 2 children with value of 30 and a value of 30, right? So we're gonna see what the generator, what the tree map generator figures out with this. This is just temporary data we can use. Okay, perfect. So get prettier to make it nicer. Okay, now when I run this, we will get a console log here. Hierarchy is not exported from D3. Why not? D3 hierarchy many datasets are considered geographic blah. Hierarchy, before you can compute a hierarchical layout, node ancestors, node data, the returned node on each descendant has the following properties. Why is this not working? Okay, what if we say yarn add D3 hierarchy? Maybe it's just not part of the default library, which is possible. Okay, so we now have D3 hierarchy. So you can say import hierarchy, yeah, from D3 hierarchy. Oh, come on, hierarchy, like that. Why is hierarchy such a difficult word to spell? Okay, and now let's rerun. It does not contain a default export. What? You're right, Magdi. I should have used the TypeScript. Export, 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 export. D3 hierarchy does not export stuff. Okay, what does it export? Go here, source, index.js, where are you? Index.js. Like that. Okay, so we've got that, and now let's see what does the tree map console log give us. The tree map console log, let me zoom this in a little bit, gives us a node that has children and has data, and those children then do other stuff, but it also gives us x0, x1, y0, and y1. We're going to be using those for the actual squares. So if we can we tell tree map how large we want it to be? Where are you? Tree map. So tree map size, if size is specified, sets this tree map layout size to the specified 2-element array of numbers. Wonderful. So we create the tree map like that, and then we say size is going to be width and height. That will give us a bigger tree map, and then round, if round is specified, enables or disables rounding according to the given boolean. Padding sets the inner and outer padding of to the specified number or function. Okay, so let's add padding as well. Padding is going to be, let's say, 10 pixels for now. I'm not sure if, I think that should be right. Treemap slice, treemap dice. Okay, so this now gives us, I think, does it? Let's see, localhost 8000. Run, come on. Why is this not running? Oh, React app, it's on 3000. Gatsby is 8000. Webpack import map, treemap is not a function. So that means we have to do it this way. Treemap blah, and that console logs the treemap itself, and that treemap then gets a hierarchy of our data, of our fake data, right? Yes, perfect. So we now have a node with all of the things. It doesn't have parents, but all of the X, Y, and everything else looks like it should be correct. So now what we can do is, what can we do? Now we're going to recursively render these squares so that they look correct. So the Mondrian thing is creating a tree map. Now what we're gonna do is say const, shall we say nodes? Const nodes are a tree map of the hierarchy, and those nodes are going to recursively, yeah, that should make it correct. So recursively render the actual thing, which is going to be, let's call it a Mondrian rectangle. Yeah, so Mondrian rectangle, which gets its node as the node. So we say root is going to be that, it gets the root node, and then the Mondrian rectangle takes in a, what does it take in? It takes in a node, right? And that node, and then it's going to render that stuff, and it's going to say const x1, y1, x0, x0, y0, x1, y1, and children are all coming from the node. So it renders, it returns. Yes, naming stuff is always the hardest thing, Megdi. So it's going to create a, it needs to be a rectangle that gets x from x0, y from y0, and then a width which is x1 minus x0, and a height which is also, who would have thought you could become an artist by painting different colored rectangles? So yes, that sounds silly, but I actually read a little bit about how Mondrian came up with this, and it was apparently he invented this style sometime in the 1920s or 30s as a result of his of spending 2 years studying neuroplasticity. He was also a research scientist, he wasn't just an artist. So he was studying neuroplasticity, and he figured out that if he decorates his studio in different colored rectangles and reshapes them and repositions them every day, it can impact the creativity in his brain, so he's then able to create art. And what ended up happening is that his tool for being more creative became the most important output of his art. So this was originally designed to influence your brain so that even as you're tired or whatever, you can still have neuroplasticity left over to create art and be productive. So that's actually kind of cool when you think about it. So this should now give us a rectangle. Now these rectangles obviously aren't very useful right now. It's also, my computer's being kind of silly. So what we're gonna do is that each of these rectangles is also going to have children. So each one is going to go to children.map, and they're going to render, let's see, children map. Each one becomes a node and renders a Mondrian rectangle. So if children exist, of course, children and children.map node Mondrian rectangle that takes the node as a node like that. So this should now give us a recursively generated Mondrian thing, but it didn't, because each child should have a unique key prop, right? That it should. So we are going to naughtily use index as the key prop. We're gonna say key is index. And now if we go into this rectangle, there should be sub-rectangles in it. Perfect. Obviously, I don't actually know if that is allowed. Like, are we allowed to have... Can rectangles nest? They also have really weird negative positions. And everything is a width and height of 0. That is weird. These guys look fine, and then it gets real weird real fast. Okay, so rectangle 0 with 500, width 700, and height 2. I know what I'm doing wrong. This needs to be y0 minus y1. Right? No? A negative value is not valid. Okay, let's console log the nodes, because clearly there is something I'm not understanding. And let's give these rectangles a little bit of a color. So for now they're going to be fill of RGBA. Let's say, let's make them gray, or let's make them, yeah, CC, CC, CC. I don't know, actually no, that's not gonna work. 128, 128, 128, 0.5. So this should make them gray and transparent. Perfect. Now the next thing, I don't think we are allowed to nest them. SVG rect nesting. That might not actually work. Better positioning and nesting boxes, graphic. No. Okay. I think rectangles don't actually nest, so we're going to do it this way. The good thing about using a what's it called? There we go. See, now they're next to each other. Why? Let's zoom this out. Actually, we don't have to zoom it out. We can go into app.js and make it 300 by 300. Cool. Okay, so we got that. Now, what just happened is that because I'm not nesting the rectangles, they're all rendering, which makes it look better. But also, we can see how they're overlapping, and because yes, so we're going to add random color within the RGB very soon. I'm just trying to make sure that I understand first how they're getting positioned. And the nice thing about using the tree map layout is that it calculates for us how to position things in space, so we don't actually have to nest them. It's always going to look correct, I think. So what is it with these nodes that have a depth of 2? y0 and y1 both become negative. But why? Okay, so height 3. Okay, let's look at the documentation again. Tree map. What are you doing, tree map? So tree map creates a new tree map layout, lays out the specified root hierarchy, assigning the following properties on root and its descendants. x0 the left edge of the rectangle, which makes sense. Y0 is the top edge of the rectangle, so x and y of the rectangle, top edge and stuff. X1 becomes the right edge of the rectangle, so if we're going from x0, then the width is the right edge minus the left edge. That gives us the width of the rectangle. And y1 why do we need to call root sum and root sort to order the hierarchy before computing the layout? Okay, so what does sum do? Evaluates the specified value function for this node and each descendant in post-order traversal and returns this node. Interesting. Okay, so let's do that. So we go here, and when we are calculating the hierarchy of our data, we also return the sum. So we're going to do d.value because you see the values here, and we also want to sort by, okay, let's do that. Let's sort by A and B. Come on, by A and B, and so we return b.height minus a.height or b.value minus a.value. Not entirely sure why that sorting is necessary, but it does seem to fix the problem. I think it's just telling the tree map layout how to better organize itself so that it doesn't give us negative values, right? And we can also now make it, let's see, what if we set width to 600? There we go, width to 600 and height to 400. We get a, let's do 350 for the height and maybe 800 for the width. Like that, cool. Now, how do we add colors? So now we need colors and we need the black edges, right? So what we're gonna do, let's see, how does Mondrian do this? So we actually only want to render leaf nodes. You see there's no overlapping here. So what we need to do, and here we have overlapping nodes, which doesn't look great. So how do we fix that? Do we actually need to fix that? Let's first play around with the tiling algorithm. What's available to us? Tree map tile. So tree map tile, if tile specifies the tiling method, built-in tile map blah. Recursively partitions the specified nodes into an approximately balanced binary tree, choosing horizontal partitioning for wide rectangles and vertical partitioning for tall rectangles. Divide tree map dice horizontally according to the value of the sum of you know what? Let's just try doing it this way. How do... Ooh. Tree map squarify with the golden ratio. Okay. So if we say dot tile with d3 dot tree map binary, like that, we can then go here. This gives us a balanced binary tree. So let's see. Then we have tree map dice. Yeah, tree map dice. So I'm trying out different tiling algorithms first. Don't like that one. That doesn't give us good results. What does tree map slice look like? Tree map slice. Nope, terrible. Tree map slice dice. What does slice dice do? Tree map Slice dice. Not a fan. Treemaps squarify. Treemap squarify. I think that one looks the best so far. Resquarify. I don't know if that looks any different. Resquarify preserves no adjacency of the previous layout computed by. Okay. We are going to keep the defaults because the defaults look great. So the next step is going to be rendering only if there are no children. So let's see. If there's no children, then we render that thing, otherwise we do not. So let's see if that works. Now we get all of the children, but that doesn't actually look good, does it? So maybe I'm trying to figure out what we can do with this, because if we only render when there's no children, then we get a very blank and empty thing, which doesn't look like a Mondrian. So instead what we're gonna do is we're not gonna render them as let's give them a border. So if we say style blah, but then we also add a stroke black, and we say stroke width is 10. Render border if there are children. This doesn't look very much like a Mondrian, does it? The problem is that they're not coming out balanced, because this is what we're looking for. So we need a way to. So turns out that this is not as easy as I thought it would be. Let's start with colors. So I'm going to take this away, stroke black. Let's take this away and let's start adding colors. For our, actually we can do a simple black stroke because that does look a little bit better. So we're going to say the colors are, what should the colors be? If it's the first one, the root node needs to have a white color. That's gonna give us the background for everything else, isn't it? Or no, the root node needs to be black. So we say get color of the node, and we're going to create a function. Actually, let's just call it get color, or just color. Yeah, let's just call it color. What? Color blah. Where are you getting this function from? So we're going to define the function. Say const color equals a function that returns. What is it going to return? If the node dot parent, because I think we get parents in our nodes. So if there's no parent, then we know that this is the root node, and we return a black color. Root node is black. Okay, otherwise we're going to, so the root node being black is going to give us the defaults. Otherwise we're going to return an off-white color. how do we get a nice off-white color? Off-white color, render border container. Yes, that's exactly what I'm doing, Mehdi. So off-white color code. Let's see. That one is cream RAL. Ooh, RAL 9010. That looks nice. 9016. Okay. What? Why is this so? Why is finding colors always so difficult? No, E2B node. I don't like that one. Let's see. What about here? No, I wanted to click this. So that looks nice. FFF. So we are going to return FF, FA, F1 like that. And that color is going, let's see what happens. Okay, that's getting better. So the problem is that we get a gigantic empty space here, which I don't like, but the rest of it is looking a lot better. Okay, now what's the next thing we need? Next we need to say, what do we need to say? How do we get these nice borders between them? That's my question. So we need to make sure that values always add up to the total amount of their parent. That's going to be something we do when we're generating the function. Yes. So I think if the values add up to, yeah, exactly. So we need to change the algorithm to feed that space, to fit the space, but we can do that by changing how we're generating our data so that it adds up. Let's see if that is actually true. So we have 100 and we're splitting it into, let's have 120 because that's going to be easier, and we split that into 40s. Yes, I could do it with CSS grid. Not sure about CSS grid. Probably could. But I'm trying to use the tree map thing because it's I think it's going to create more pleasant. Yeah, I think it's going to look more pleasant if we do it that way, this way. So what if we change these to 80 and that one to 40? So the question is, why isn't it filling that space? Because it's like refusing to do that. I think that's a rendering error. Let's see if these guys all... So we have 40 and we need to add this up to 40. Let's see, what if we say 30? So we have to say 10, 10, and 10. Interesting. Value 10, 10, 10, and then these guys value 3 and 3. What do we get? So what if maybe every level needs to add up to 120 then? So we have 40, 40, and then another 40 here, and that level adds up completely to 120. I think I need to figure out how the tree map layout is actually doing this. That would help. And I think doing it with CSS grid would work, but it wouldn't give us the nice golden ratio support that we get here by default. Let's see what happens if we get these guys adding up to 120 as well. We're now basically trying to figure out how to So Matteo, there's a an algo to generate which, when you say those, which one, what's those? So if we say 60 and 60, what's gonna happen now? It doesn't make any sense to me. Okay, so Mondrian apparently was a lot smarter about this than I am, and he was doing it manually. I always thought that the tree map algorithm would try to fill the entire space. Yeah, so the rectangle sizes and ratios are they're set by the tree map squarify algorithm. The squarify tree map algorithm by Brute and others. So this one. So this is the algorithm we're using. Right? Let's make it more explicit so that it's obvious. The dial dot tree map squarify. That's the algorithm we're using. And this is the description of that algorithm, which I should probably read, but I'm not going to bore you all with me reading this. I'm just going to use it as research for basically when I'm writing the article. But yeah, when I write the article about this, I'm going to go through the squarify algorithm. Until then, let's see what happens if we get the width and the height to be more just generally closer together. That did not work at all. Nose Doska, I'm not sure what you mean by exclamation keyboard. Why is it not filling up the whole thing? What if we add another, hey Nazdoska, what if we add another one of these guys? I was hoping it would go down there, but no. What if we add more children? Like that. Yes, so I'm using the truly ergonomic keyboard and I'm waiting for the new one to come in the mail. So this is what I'm using. Or I'm using an older version of this keyboard. And the cleave I'm waiting, I already ordered it and I'm waiting for it to come. But yeah, what if I just do this? So the part I don't understand is why it's leaving. Yeah, the keyboard really helps, but I still don't understand why this is leaving the space. What if everything has a value of 1? 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Interesting. Okay, so if everything has a value of 1, it still leaves things all over the place. And if I comment this out, it's going to create that. What if we do end up using a different tiling algorithm? Or, aha! To sort nodes by descent, node sum, the compare function is passed 2 nodes rather than 2 nodes data. For example, if the data has blah, so circle packing. Similarly, to sort nodes by descending height, greatest distance from any descendant leaf and the descending value as is recommended for tree maps and icicles. So what if we change the sorting algorithm so that they are just sorted by descending value instead of height? Okay. that looks the same. Let's add this there. Okay, so when we are sorting by descending height, I see what's happening. So this is going to be sorted just relatively randomly, but we can also sort them by, if we sort them by the reverse order, then we're going to have the smallest one up left. Yep. Alright, that makes sense. We're basically saying or render the smallest node last, so that's going to be the last one here. What if we don't sort them? What happens then? Alright, cool. What if we don't sum? Then they all get weird. Okay, let's move on. The next thing we're gonna do is add more colors. And actually we can change treemap binary, and I think that's gonna give us perfect. That actually gives us what I was looking for. Alright, that's gonna be better. So instead of trying to catch ratios and fancy things, the treemap binary gives us proper full packing of everything. So everything, all of the children always fit in the parents, which is great, because then what we can do is, what can we do? We can then, when we're rendering, the root node is black, that gives us the border. Then we have default is off white, but I think this is, what if we do it this way? Ah, no. D new. So I want it to be maybe a little less yellow, because it's kind of very off-white right now. But let's see. Else, so we're going to create a, let's create a ratio between height and width that's going to inform which color we're using. So if we look at Mondrian's art, you can see that large squares, everything that is basically a square is red. So we're going to say if ratio is more than or equal to 0.9, then we're going to return red. And we're going to get the const width is, okay, let's do it this way. Width is x1 minus x0, height equals y1 minus y0. So then the ratio becomes width divided by height, right? And that also means we can use width here and we can use height here. Why did it do that? Prettier, sometimes you really do the dumbest things. Okay, so we get the ratio, which is going to be red. Okay, if the ratio is more than equal to 1, then make it red. How much is the ratio? This is definitely like, why is that ratio, why does it look like that? Because let's see, what is the width and the height of this thing? So if we go and if we say 258 divided by 146, right, because we need to always divide the highest one with the lowest. Yeah, so ratio, if the width is more than the height, then we go height divided by width, otherwise we go the other way around. And now nothing is going to be the color of the parent. Why do you think I need to? Oh, Umesh, you make a good point. I do think I need to consider the color of the parent. Okay, but let's see. So it needs to be either red and other, let's see, else if it's more rectangular, so if the ratio is more than or equal to, let's say, 0.7, then it's going to be blue, else let's see if the ratio is more than or equal to half, then we're going to return yellow. And we can consider colors of the parent later. Yeah, we do need to consider the color of the parent, don't we? But I think the next thing we have a problem with is that there's just not enough white anymore. So okay. Okay, so that they know what's the next color to get. Yeah, that could work. Problem is, I'm not sure. I think what we need now is just more children and everything, and that's going to help. So let's try to let's make a commit here and say git add source, and we say git commit -a-n. We can, I know what we're gonna do. We're gonna actually assign a color at when we're building the when we're building the thing, we're going to assign a color when we build the data, and that's going to make our life easier, I think. So git commit -a-n basic rendering, and now we gotta more children. Yes, we definitely need to make more children next. So that's what we're gonna do. We're gonna go rendering and creating children. So when we create the data, it's a const data equals, actually this is gonna have to come from props now, because we're gonna make this stuff configurable, or like there's going to be parameters that you can tweak and get different values. You know how children are made, yes? Candy cane, I do. Let's see, const Mondrian data equals generate Mondrian, and blah. Actually, we can do data and go back up here, say const generate a Mondrian, which is going to be a function that does what? It needs to return a value, and that value is going to be, let's see, how do we decide how many children to create? And then we are going to make it so that values always add up to however many children we have. Let's start with a value here. So a value is going to be the value, and then let's say we want to create children, where we have d3.range of let's always do 10 children. So const n equals 10. Will that work? That might work. So we go d3 range.n and we map, and for each of them we create a generate Mondrian with and we're gonna say depth equals 0, generate Mondrian with a value divided by n, and a depth of depth plus 1, right? Like that. That should, in theory, what am I doing? Oh, value is value divided by n, and then tip. Okay, so we're now recursively generating our data set. For each level, we're creating 10 children we start with a value and we're making sure that each value always adds up to the full sum of the parent's value. This should give us a balanced, this should in theory give us a balanced tree, I think. The problem is going to be that it's going to be too uniform. So you'll see that all of the Mondrians are going to be exactly the same. So we have depth plus 1, and we say we only create children if depth is less than, let's say, 4, then we create children, otherwise we say no. Like that. Okay, so if we are currently less than 4 levels deep, we're going to create more Mondrian children, otherwise we do not. And this is now going to die. Value of undefined is undefined because we have to say here, let's start with a value of, let's say 100. And let's see. So this is now going to, see, it's too uniform. Everything looks too much the same, but which means we need to add some randomness, and that's going to make things a little better. So what do we do? How do we add randomness? First of all, we don't always need exactly 10 children, right? Const color, where are we? So instead of n equals 10, we're going to say math.random times 10, and we're going to math.round so that we get a round number every time. And this is now looking pretty silly. Okay. That still doesn't look very great, does it? Let's see, what if we say math random times 5? That's a little better. The colors are still very off. Sometimes it just doesn't give us anything. We also need to go only 3 levels deep. I think that, okay, that looks a little better. Problem is that this is now very how should I say, it's like, it's too random, isn't it? It doesn't have that artistic vibe of a Mondrian art piece. So what if we only go 2 levels deep? Okay. Now the next step is going to be generating colors here. Math random times 6. Okay. And to get the colors, we're going to, instead of that, we're going to say the color is going to be math round plus 1. What do you mean by round plus 1? Oh, no, actually, Magdi, I'm not sure what you mean by math round plus 1. So the color is going to be color, which also will come from, where will that be in the node? Let's make it white for now. And console log the node, and we'll see. So here, when where are we generating them? Here, we're going to design a color. So we're going to say color will come from basically a weight. How many reds do we want? How many blacks do we want? How many yellows? And so on. So we say math dot let's say create color, and we say const create color, which will be, so we need to get the probabilities of, yes, so how likely are we to create a yellow, a red, and so on. So red RGB, no, red, blue, yellow, so red, blue, yellow, black, and we say so if we want a third of them to be red, then we need math.random. So how do we ensure that about a third of the time a random function returns red? This is gonna be hard and also kind of silly. So we can say const wow, I am totally blanking on this. Yeah, I think Magdi, you're right. So how do we create a random function that has, well, it doesn't need, so candy cane, basically the idea is that when we randomly pick a color, we want about a third of them to be red. So it's not exactly a third, but it's about a third, which is going to be silly. So we can say if, say const rand equals math.random times 100. That gives us basically, then we say if rand is more than God damn it, why am I blanking on this? How do we create a function with a probability distribution? Random method probability distribution. Theoretic formalization of probability theory, a random variable is defined as a measurable function x. This seems complicated. So the probability mass function specifies the of two dice rolls of discrete probability distribution. This is all very complicated. So I think instead what I'm gonna do is, I know what we're gonna do. We're gonna make this easy. We're going to generate an array that has of like an array of 10 elements, and we're going to create as many reds, blues, yellows, and blacks as we want, and then we're going to pick a random element, and that's going to be our colors. So we say, yeah, and we're going to shuffle them and then pick one of them. There's the sun is reflecting from a skyscraper right in front of my window directly into my eyes, so that's why I look very highlighted right now, and also I'm squinting very hard. So we can create const probability space, which will be d3 range red dot map, like that, of like that, red. Actually no, we can do it this way. Yeah, new array red dot fill with red, new Yep, new array blue times fill with blue, like that. The new array of yellow, fill yellow, and new array of black, fill with black, like that, comma, comma. Okay, so that gives us our probability space. We also need to have a probability space of what should the probability space be of what was I gonna say? Oh, how much? So we need to have about as many whites as we have other colors, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, yeah. So then we say new array of red plus blue plus yellow plus black. We fill that with not white, but what was the off-white color we used? Hashtag FF, FA, F1, like that. And then we return. How do we pick a random number? I think there's a D3 has a helper for that. Where is it? D3, come on D3, help me out. I know, I'm pretty sure D3 has a random random selector for basically for a random element in an array. Random numbers, uniform, exponential, logarithmic, Hall, Bates, shuffle, D3 shuffle, randomize the order of an array. Cool. So we're gonna return the D3 shuffle of our probability space, and we're going to get the 0th element. And now we're going to create color with so these are going to be parameters that we pass in. So actually, let's do it this way. Create probability create weighted probability distribution to pick a random color for a square. Okay. Get that, and then here we're going to say red is going to be 0.3, blue is going to be, oh, and we're gonna have to multiply them by 10. So let's do times 10 times 10 times 10 times 10, and then here we can do times 10 times 10 times 10 times 10, like that. So blue, let's say we want 20% of the squares to be blue. Yellow, we want, let's say, 0.6% of the squares, and black, we want 0.4% of the squares. So we should now get oh, we're not using the colors just yet, are we? We need to figure out where the aha, so we have to get it from the data in a node. So create color, that's the color, and then when we're rendering down here, we say the fill comes from node.data.color. And let's see what happens. Aha, that kind of worked. Very kind of. Okay. Now the next step, we're gonna give them all one of those what did we say? They need a border, right? Because in Mondrian everything has like a really fat border. So here when we are doing the padding, let's set padding to 5. And we say stroke width is also 5. That looks better. No, it doesn't. So my distributions are all wrong, but damn, this is hard. Generative art is difficult, guys. Who would have thought? But what we can do is add status git commit -n use generative params for colors. Okay. I don't like this one just yet. Times 10. No. Okay. Yeah, Candy Cane, what are you doing with databases? Or are you saying I should go back to the backend and handle some databases? Why is generative art so difficult? So let's try adding some slider components here. Input slider, is that what it's called? Input slider. How to create range sliders. Input type range, perfect. So we're gonna go like this. A div, and we say input type equals range, name equals red, min equals, let's do it this way, range raw, yeah, range which is the name of red and a value of, let's say 0.3. So now we create a range component, const range equals name and value, that, and we render, return input range equals input type equals range, type equals range. Yeah, TypeScript is fun, isn't it, Candy Cane? Type range, name equals name, and min is going to equal 0, and max is going to equal 1, and then value is value, like that. Let's see if that renders. Cool. You provided a value prop to a form field without an onChange handler. This will render a read-only field. If the field should be mutable, use default value. Okay, and then onChange, we're going to say onChange. onChange like that, and then the onChange function. So we're going to say const, let's see, use state from React, and we're going to say const red and set red ratio, and set red ratio is going to be use state that starts with 0.3, value red ratio, and set red and on change equals set red ratio, like that. Cool. Okay, that's use. Yeah, I'm doing use state. Magdi, are you asking what use state does or whether I should use it? Okay, so how do I set the default? Step needs to be 0.1. Step equals 0.1, like that. Now 0.05. That's going to be a better step. And then here we're going to pass in red ratio. Yeah. Color ratios. Let's say color ratios equals a function that's going to look like that, red ratio. And then we go into the Mondrian, and in the Mondrian we say color ratios here. Mondrian gets color ratios, and we pass the color ratios into our generate Mondrian color ratios. And then in color ratios, Mondrian rectangle, where we're generating the Mondrian value, color ratios, blah. We also pass color ratios here, and we do this, color ratios. Okay, and now it's going to complain that things aren't working, so we gotta copy pasta this. So set, what did we say? We need yellow ratio, so red, blue, black, and yellow. Yellow ratio, set yellow ratio. This part is going to be a little silly. Blue ratio, set blue ratio, black ratio, set black ratio, like that. Then we use them here, name red, yellow, blue. Okay, so this died. I need to update. I'm starting to think that my camera batteries are lasting less and less long. Where are you? So that's the camera. Am I moving again? No, I'm not moving again. Camera live. There we go. Okay. So I am back. Hello. Set black ratio, red ratio, yellow ratio, set yellow ratio. This part is kind of sucky. This is also why you should not be copy pasting code like I am, because it gets pretty silly pretty quickly. Set black ratio, and then here we do yellow is yellow ratio, blue is blue ratio, and black is black ratio. Okay, voila. So now when I tweak this, it dies. Invalid array length. Neat. Okay, so we're gonna have to do some, actually let's add a label on this stuff. What did I do? No. Let's make it a label with the name, break like that, and label red, yellow, blue. Wow, why did that not work? Div, and then we're going to say style equals display inline block. There we go. Okay, so we now have blue, name blue, red, yellow, blue, black. Okay, so we've got the ratios. Now we just gotta see why it doesn't work, because that should not be invalid array length. Why is it getting confused so very quickly? Let's console log what we're actually getting. So here in Mondrian, we're going to color ratios, Mondrian rectangle, console log color ratios. Okay, red, yellow, blah. And what happened? Synthetic event. You have 30 minutes remaining. Okay. Right, because I can't stream on Crowdcast for more than 2 hours at a time. How are we doing on time? I have 30 minutes remaining on the timer. Perfect. We're actually making great time on this. So let's see. I'm getting a synthetic event because what I need to do is not do it like this. We need to get an event, and then we're going to change it with event.value. I think that's gonna work. Nope. Event target.value. Nope, that one's also not it. It needs to be a number. So a number of onChange event target.value, and then it's gonna work. Nope. Dude, how? Let's see. Number of 0.35 should work. F target.value. Yeah, so that's what I'm doing, Mehdi. It's just being silly. You see, it's... Oh, I'm an idiot. Number needs to be fed into the onChange function, not the onChange function whatever. Oh, come on. Invalid array length. 0.35. Okay, so what if we set the step to 0.1? Yeah, number should be inside the inside onChange. Okay, so that's kind of doing things. You see, now we're just getting a bunch of red ones, which is pretty cool. But the next thing we gotta fix is that who can guess what's still wrong? So we probably don't want to regenerate the shape of the, when we're just changing the color, we don't want to regenerate the whole thing. So we're going to fix that by generating the data here and passing it into our Mondrian down here. So we're generating the Mondrian once and then always just updating the data. Yes. So we get color ratios, and here we're going to get a Mondrian should we just call it data? Data will make the most sense. So data, and we're going to go here. Memo expensive stuff. I don't think we really have that much expensive stuff right now. We can memo it in a little bit. So we're going to const, let's see, what should we const? Actually no, we are going to generate, no, we are going to generate it out here. So we're going to say const Mondrian equals use, should we use an, no, use memo. Yes, let's use a memo. Use memo, and use memo is going to, yeah, so that's exactly what we're going to start using the use memo for, is that we're not going to be generating the data every time. So let's see, generate Mondrian. We're going to only generate the Mondrian the first time. Like that. So generate Mondrian, use memo. We generate the Mondrian like this. Actually, what can we do? Create color. So create color is going to be this function, which we take from here and move it into the thing. Yeah, I'm using very descriptive words, aren't I? So we're moving where we generate the data into the main app component. Import *sd3 from d3. We get that. And now here where we have the Mondrian, we are using memo so that we're only calculating this once. And instead of color ratios, like this, we're going to pass in red. Let's just do it like this: red, yellow, blue, black. And we can rename this red, yellow, blue, and black. So this gives us the ratios that we then have direct access to. We create the generate Mondrian, and we return generate Mondrian of value 100, like that. Then we don't need to pass in the color ratios anymore. So this should now give us a stable. This should now give us a stable thing. Actually, let's return the ratio word here so that we have fewer things to change. Color black, black, black. And we change it here so that this also actually makes it easier to understand what these things are doing in the first place. Okay, so we've got that. So now we're generating it. We need to pass it into here. So into the Mondrian, we get data. So data equals Mondrian, like that. Okay. So this is now still. So you see now, even though I'm changing this, nothing's changing because it's memoized, so it doesn't know that it needs to change, which is great, because then here, what's this? React hook use memo has missing dependencies. Black ratio, blue, either include them or remove the dependency array. I want the dependency array to be that way. Like, I am purposefully not including those dependencies, because what I'm gonna do is change Mondrian to have a let, and then we're going to recalculate the colors every time. So we're going to say Mondrian equals update colors of the Mondrian. How do we do that? So let's actually define it here. Const update colors equals what does it need to get? It gets a node, and for each node it returns the color, which is going to be the same call that we have here. Recalculate node colors on every render. So we update the colors, color create color, and then for the children we say if there are children, we do node.children.map with update colors. And we only do that if there are node.children. Otherwise we return null. Okay, const update colors. So then we say Mondrian equals update colors of Mondrian. Okay, now let's see. What is it complaining about? because it needs to also return the rest of the node. Okay, so now when I change the ratio of yellow, you see the colors are changing, but the layout itself is staying the same, which is pretty cool. So we're adding a bunch of this stuff. Think that works pretty well. Yeah, I have no idea. I feel like we should also add some rules so that things that are too big can never be black, because I think that will make the the final thing a little better. So let's see, git status, git commit -a-n, dynamically change color regardless, change color without reshuffling, without relayouting. Okay, so we're creating those and we're not relayouting. So now the next thing we can do is, let's see, what should we make next? What should we add? I think people will want to change the width and the height. That could be useful. So let's see, the width and the height. So const width set width equals use state with no and we start with 600, and we say const height and set height use state. What are we using right now for the height? 400. Okay. This all is starting to look kind of silly, but how do you add events to the tiles? Example, on click on hover. We can do that. Let me just add this first. Div, and we say label width, input type equals number, right? Number, and we say value equals width, and on change equals event, and we say set width with the event.target.value, like that. Come on, right? Width, and then we can also add the height. Height, set height, height. Okay, so now we gotta actually recalculate these guys on width and height changes, do we? I think we do. No, actually we don't. So width and height are the same. So we pass them in width and height. And let's see. If we change this to 300, yay, that works. 500, 600, cool. Perfect, okay, that works. Now let's try to add an event on the tile itself, but I also want to figure out a way to make this. I feel like the color, oh yeah, the colors are changing every time we re-render. Ha! That's... We need to use memo that. So, let's see. Use memo. Here, we're going to only update colors when red ratio, yellow ratio, blue ratio, or black ratio actually change.
Alexa, turn on the lights.
Okay, So now, if we change this to 500, it has the same colors as it did before, but if we change this, the colors start changing. Yay, okay. So events on the forms, on the tiles themselves. This is also getting to be, hey Jesse Skinner, I'm happy you like that, what was it called? I'm happy you liked the wow, I am blanking, but oh, I'm happy you liked the interview. Yes, I don't know how I blanked on that word. I must be getting hungry. Oh, I know what we can do. We're going to move all of this stuff into a separate use Mondrian hook. Let's see. Fantastic, yep. Use Mondrian, which gets red ratio, yellow ratio, blue ratio, and black ratio. Very nice. And then we're going to define it. Function use Mondrian, which getting so tired of typing those.
Do you think you're good washing?
What? No. We got that stuff. Paste it here, like that. And now everything should work. We just need to actually return it. Return Mondrian. Let Mondrian equals like that. Use Mondrian generator. And here we're going to rename this to use Mondrian generator. And then we can move this into a separate file, just so it's easier to read. Import use Mondrian generator from /use Mondrian generator. This is just cleaning up the code base a little bit. Export default use Mondrian generator and import use memo from React. Use Mondrian generator.js. What do you mean by Candy Cane when you say that I'm thinking about the code and also translating into English at the same time? I guess I kind of am. I've been live coding for so long now that I'm kind of used to it. It's D3 from D3. Oh, I stopped it. Yarn start. Okay. Aidan Gal. Oh yeah, so I always actually think in English, even though I'm not a native English speaker. These days I kind of mix and match and think in both English and Slovenian at the same time, but mostly when I'm coding I think in English. So Aidan G. You use a lot of funny letters in your name, but I hope you're still there because we're going to add some very simple, just like a simple thing to interact with this stuff, because I think you asked, so I should really add it. So we're going to, on each rectangle, we're going to add a little interaction. So we're going to say on, let's say, mouse over. What should we add? Let's do an on click. On click is going to, let's see, what should we say? On click, let's do it this way. Alert hi. So this is a very simple interaction. If you click on a rectangle, you get a hi alert. But what I want to do is make it so that this hi alert is going to tell us something about the node. What should it tell us? I wonder if there's a random fact generator for art. Art fact generator. That would be cool. Amazing fact generator from Mental Floss. Random fact generator.net. Is there an API? random fact generator API. Yeah, it could tell us the color. That would be cool. I just want to see if this exists. Okay, we can deal with that some other time. Let's alert node.data.color. Okay, so bam, we get the color, and that's about it. This node is like that. This node is red. Wonderful. Okay. So that's how you would add a basic interaction. We didn't do... Originally I had an idea of adding transitions and a bunch of cool stuff. That didn't happen. But it doesn't need to happen because this is interesting enough, I hope. So one thing we can change is the default ratios here. Let's use 0.2 of red and 0.4 of yellow. I want 0.1 of blues and 0.2 of blacks now, like that. Okay. Yeah, I've done enough transitions in other places, so I'm not gonna add them here right now because that would be, well, we have another 9 minutes to play around and see what we can add. See, this is why I created the timer. But there's a lot of stuff about transitions. If you go to reactfordataviz.com/articles, we did a bunch of transitions here last time. If you go to this article, this article has lots about transitions, like that. What we can do, I think we need to make it so that blacks have a... Basically, if the rectangle is too small, if it's too big, it should never be black. So let's see. Red ratio, yellow ratio. And also we should make this one should be... Yeah, the Moore's law visualization was really cool, wasn't it? What can I do here? We need to change this so that it creates more subdivisions. Let's see. Let's add a range for range subdivisions. Subdivisions, and let's get an n, and we're going to multiply that n by 10. Set subdivisions n times 10. Okay, and then we go here and we say const subdivisions set subdivisions equals use state, and it starts with point. What should it start with? So it goes from 0 to 1. So let's say it starts with 0.5, and we're going to put subdivisions into the generator. Then we go into the generator. The generator, where are you? Use Mondrian generator. It accepts subdivisions and uses them here times subdivisions. Okay, so why is that jumping so much? Right. Because when we're setting the value here, where am I? Here, subdivisions needs to still be, can't multiply by 10, so we're going to just pass in set subdivisions. But when we're doing it here for the Mondrian generator, it's going to go times 10 for the subdivisions, and the memo is actually gonna have to depend on subdivisions. So this will make it so that we can configure how many of these guys we want, except it's not actually working. Why isn't that working? Let's see. Console log subdivisions. Subdivisions. If I change this, that is definitely changing. Okay, so that changes. Is it going into the memo, console log subdivisions? Yeah, it's still going into the memo. And then, so it generates the Mondrian, right? Console log let's do console log of n. Console log n. So we change subdivisions. So it's definitely changing. Now why isn't it? Ah, I know what we can do. We can go subdivisions times 10 minus the depth. So each time you go down, it's going to get subdivided less. But it's still not re-rendering, which is frustrating. So this needs to also depend on subdivisions. Will it work then? Yep, there we go. Cool. Okay, so that's starting to look a lot better, isn't it? And let's make it +1 like Mehdi said earlier. So it's going to be 1 plus math.random. So we always get at least some. Cool. Now what else can we configure? We can also configure the max depth, right? So let's add that. Max depth. And use Mondrian generator. So we say const max depth set max depth, which is going to use state, and it's going to be exactly the same thing as before. It's going to start as 0.4, and then it's going to have a range here, max depth, set max depth, right? And then in the Mondrian generator we get the max depth, and if the depth is less than 0.2, we say if it's less than max depth times 10, null subdivisions max depth, and the color also needs to depend on max depth, or actually, you know what, this needs to depend on the Mondrian, not on the max depth. Because when we generate a new Mondrian, then it should be cannot be property children of undefined. What? Max depth. If depth is less than max depth times 10, then we do stuff. Max depth comes from there, max depth. Okay. What if we change this back to subdivisions and to max depth? I don't understand why this doesn't work. Less than 2? Would that make you work? Suddenly, what am I doing wrong? It's suddenly not doing the things. So max depth, set max depth, use state 0.4. Let's do it to set it to 0.2. So it renders here data Mondrian, use Mondrian generator, which does get the depth. Use Mondrian generator max depth. I can't tell what I changed. So update colors node.children cannot read property children of undefined. The session limit reached on Crowdcast. Sorry if anyone was watching there. There was only like 2 people, which I know is still really bad for me, but I'm just trying to see why. Oh, why is this not getting the Mondrian anymore? When did I change that? Okay, so max depth. So this now needs to depend on the Mondrian. And then we use the max depth here, max depth times 10. Yeah, PhD horrible. I was reading the error in the console, but it wasn't being helpful. Okay. So that's pretty cool now, right? I think that's pretty cool. You can kind of mess around with this. I think we need to make the there's like something weird that happens when you go to when you have a lot of these guys. So max depth needs to be divided by let's do max depth times 5 instead. Yeah, that's better. Cool. Okay. So I'm gonna call this good enough now. We had fun. At least I had fun. So now it's time to make a little tweet about this and just show what we created, and that's gonna be that for today. I really wish this was centered, but I don't feel like messing around with centering this stuff right now. Let's do that. Okay. So why did it create such a boring one right away? That's silly. Okay. Oh, I know why. We need to here, let's set the depth to 0.4 at first. There we go. That's gonna give us a prettier default. And I do think I should have added some sort of what's it called? I don't know what. Oh, let's see something else that we can do. What if we sort them randomly? Sort b minus b height. What if we just do this? So now they're gonna be sorted instead of by let's see, what if they're sorted by random? Math.random. If that's more than 0.5, then we return. No, we can do 0.5 minus math random. So now they're going to be in random order, which I think creates more interesting results, right? Doesn't it? Yeah, I think it does. Cool. Yeah. Okay, well, that's as far as we got. Generative art turns out to be pretty darn difficult, but you can expect an email in your inbox in a couple of days. I'm gonna write up about what we learned and how this worked, and yeah, so that's it for today. Thanks everyone for watching. I will see you again next time.